All right, we're trying to prove that this particular transformation is an isometry, or isometry, or whatever. Anyways, we're proving that it preserves length, which means that it moves shapes, say across the coordinate plane to a new location, but it doesn't stretch or distort them in any way. It keeps them the same length. All right, all segments will end up the same length. So here we take a look at what this thing actually does. Basically, it takes any pair of coordinates x, y, leaves the x coordinate alone, and it just changes the sign of the y coordinate. So for example, the point 1, 2 would become the point 1, negative 2. And the point 3, 3 would become the point 3, negative 3. Right there. And this would be m prime and n prime. And over here, the point negative 3, 1 would become negative 3, negative 1, p prime, and negative 5, 4 would become negative 5, 1, 2, 3, negative 4. And this would be q prime. So essentially what it does, it just flips things across the x-axis. As a reflection across the x-axis. So we need to show that these two segments are the same length. So this one's the same length as that one, and this one's the same length as that one. And we can just kind of eyeball that and use Pythagorean theorem to show that they're the same length. But just two specific segments isn't enough. I have to show that any possible segment that I might come across will stay the same length. So what we're going to do is we're going to come up with a generic segment. We're going to call our generic segment, we're going to have M be the point AB, and N be the point CD, and then M prime will be A negative B, and N prime will be C negative D. And we're just going to show that the distance between these 2 points is the same as the distance between these 2 points. What is the distance between these 2 points? Well, we're just going to use our distance formula. So we'll have, we've got the square root of A minus C squared plus B minus D squared. So you just find the difference between the x coordinates, and then we square that. And we find the difference between the y coordinates. We square that, and add them together, take the square root. On this side, got the same kind of thing, except now it's A minus C squared. And now it's negative B minus negative D. Negative B minus negative D squared. Okay. So let's see. Well, first thing we'll do is we'll square both sides. And that just gets rid of the square root bracket. So then I've got A minus C squared, B minus D squared equals A minus C squared plus negative B, and let's just rewrite this as plus D. Plus D squared. And now, notice we've just got this on both sides, so we can just get rid of that. So let's see. That leaves us with B minus D squared equals negative B plus D squared. Okay, so far so good. And notice here that this, we could rearrange this as B minus D squared, and then over here I'm just going to rewrite this as D minus B squared. Now, by the way, if you ever test this out, if you take two numbers and you subtract one from the other, right, and then you reverse the order and subtract the other way, you just get opposites, right? So for example, 1 minus 3 is negative 2, and 3 minus 1 is positive 2. Okay? So whatever these two numbers are, they're going to turn out to be just opposites of each other. And when you square opposites, you get the same answer, so we're going to end up with the same thing. But let's see if we can't do a little expanding here. we'll expand this binomial, and we get b squared minus 2bd plus d squared equals d squared minus 2bd plus b squared. But then notice, cancel, 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 and 0 equals 0. And what does that tell us? Well, this is a true statement. And we could work backwards, and as long as everything that we do is algebraically sound, we're following the rules of algebra, if this statement is true, then I could add d squared to each side and it's still true. I could add negative 2bd to each side and it's still true. I can add b squared to each side, it's still true. I can rewrite these as these squared, these binomials. It's still true. I can take this step, still true. I can add in the square of a minus c on each side, still true. And I can take the square root of both sides, still true. Right? So if this is true and we followed all the rules of algebra for equations, then our original statement must also be true, which means that the distance between these 2 points is in fact the same. Meaning that if I just take 2 generic points, they don't actually have real numbers, not specific examples, I could plug anything I want. I could pick A and B and C and D to be anything I want, and I could just replace them in this formula right here, and I will always get the same distance on both sides, which means that this transformation here, which flips things across the x-axis, preserves length. Right? So a segment that's flipped across the axis will stay the same length, which, by the way, is important because if I take a triangle and I flip it across the axis, then all the side lengths, they are going to all stay the same length, which means that the new triangle will have the same side lengths as the old one, and therefore it will be congruent to the old one. All right.